Hello, ladies and gentlemen. Today we are going to take a look at solving systems of linear inequalities. So not systems of equations, but inequalities this time. So for this, you're going to need pencils, probably preferred, as well as a couple different items that are different colors, because we're going to be graphing multiple things on the same axes, and so sometimes different colors are helpful. A calculator, maybe a ruler to help you draw some straight lines in there today. So let's take a look at our learning targets. Our learning target is that you can graph and solve systems of inequalities. So we're taking this up from just an equation now to an inequality. So what we were doing was finding intersection points for systems. Because they were lines, right, linear, we find that solution point by the place that they would intersect. So the x, the y that works in both equations was represented by that intersection on a graph. Now what happens when we take it from equations to inequalities now? So instead of an equal sign, we have a greater than, less than thing going on. That means we're going to incorporate not just the lines, but the shading. So we would graph one and shade, and we would graph the other one and shade. But the solution is not just a single point where they cross, but it's where the shading overlaps. We're trying to find the region of points that are representative of the solutions of the system. So all the points that work in both inequalities would be where the shading is overlapping. So that's our plan for today. Let's look at a couple here to see if we can figure out how we do this. So in both of these, we're going to make a picture, a graph, so you're going to need to draw some little graphs there. We have x plus y is greater than -3, so I'm going to go ahead and graph that one first. X plus y is greater than -3. Now we graph by getting the y alone. Oops, so I'm going to get the y alone. We'd have y is greater than -x minus 3. So by subtracting the x over, we have the y by himself, and now we can make a picture. The first dot is on -3 on the y-axis. And then from there, we would do the slope of down 1 over 1, down 1 over 1, down 1 over 1 because of that negative slope. Now, when we connect the dots, be careful about the solid line, dash line business again, guys. Be careful about that because this is just a greater than, not a greater than or equal to. When we connect these, we need to connect it with a dash line. So I'm going to dash that line as straight as I can here, and then we're going to go ahead and shade. Because it's a greater than, we want to shade above this line. So all of these points on this part of the graph are solutions to that first inequality. But we have a second inequality we need to graph. So I think I'll switch colors here and maybe do that one in blue. We're going to go ahead and take this one, -6x plus y is less than 1. We're going to add the 6x over to get the y alone. We have y is less than 6x, that's the slope, plus 1, that's the y-intercept, the b. So when we make a picture of that one, we're going to go ahead and start at 1 on the y-axis and then do a slope of up 6 over 1. Maybe I'll draw one more, down 6 over 1. Down 6 more over 1. Try to make this line the best I can here. And then we're going to go ahead and draw this and connect it again with a dash line. This one's almost vertical here. Dash line. And then we need to shade. Now shading of this line means I'm going to shade less than underneath. So I'm going to shade underneath this line, and that's the whole part of the graph, even the part that's unshaded, and the parts that's already shaded red get shaded again. Now where we're looking for the solutions, right? Where the shading overlaps or intersects each other. So the solutions on this graph would be right there. This is the solution region. So it's a region on a graph, not a single point that we're looking for. It's where that shading overlaps. So sometimes when people shade, they'll write to the side, this is the solution with an arrow. Oftentimes, other times they'll take a third color and like shade that part darker to say, hey, this is the solution region right in here. If you want to do that, that's fine, but you don't have to do it that way. You can just go ahead and shade that, or you can put that arrow to the side, either way, okay? So now let's go ahead and go to another example here. Two inequalities again. We're going to make a picture, same idea, finding where the shading overlaps or intersects. So we have 4x plus 2y is greater than or equal to 8 first, and we'll go ahead and solve for the y. 2y greater than or equal to, we'd have negative 4x plus 8. We're going to divide everything by 2 now. Here's my first inequality that I need to graph. So I'm going to place my first dot on 4 and do my slope of down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. That's the slope in this equation. And then we're going to go ahead and draw that straight line. This one is not dashed. Okay, and then we're going to go ahead and shade above because it's greater than. So I'm going to shade above this line again. Beautiful. And then we're going to graph the other one. So I'm going to switch colors again here. Grab this guy. So this is y is less than negative 2x minus 3. Already solved for y. Best day ever. So we can go ahead and graph negative 3, down 2 over 1, down 2 over 1, down 2 over 1. Oh, looking like we have some parallel lines here. Interesting. Okay, we're going to go ahead and draw in that dash line. Lovely. So the lines are parallel, and at first you might be thinking, well, all parallel lines have no solution. But remember, we're not looking for the point where we cross. We're looking where the intersection crosses. So we won't be able to tell that until after we've shaded this time. So we're going to shade less than this line. So underneath is going to be shaded. And now that I've done the shading, I can see, you know what, this is a no solution situation because the shading never overlaps or intersects. So next to this graph, I will write no solution, but it's not because the lines are parallel, it's because the shading doesn't overlap. Is there a way that I could have changed this problem to make the shading intersect? It would have been easy. All I would have had to do is change this sign to a greater than, and then we would have shaded the other side of the line, and we would have had a huge region of solution points. So be thinking about that when you're graphing, that you're looking for where those regions are, that where the shading overlaps each other or where the shading is intersecting, okay? I want to thank you for taking good notes.